Okay, so problem 4.6. Obtain the sum of the series sum from n equals 1 to infinity of 1 over n cubed plus 3n squared plus 2n by rewriting it as a telescoping series. Okay, so we're given it everything. Okay? And the hint for this is to expand the general term in elementary fractions. Okay, so if you haven't seen elementary fractions yet, okay, the idea is that we will devote a lot of time to this in the integration unit, right? So the idea is that we can factor out the denominator, and this is actually n times n squared plus 3n plus 2, and if you work it out on your own, this is n plus 2 times n plus 1, right? So we can factor out the denominator in the simplest factors possible, and we know that when we have a denominator like this, it comes from separate fractions that have been joined together, right? By multiplying them. Okay, so we know that this rule applies a times n plus 2 times n plus 1 plus b times n plus 1 plus c times n plus 2 equals 1. Okay, this is the rule that we need to apply. Okay, so now in order to solve this, we can either substitute, so expand this and then equate the polynomial terms in one side to the polynomial terms in the other side, or we can give numbers to n, right? So we can say if n equals 0, then this term and this term cancel out. So we have 2 times 1, 2a equals 1, so a is 1/2, right? Now if n equals minus 1, then n minus 1 equals 0, so this cancels out, and then we have minus 1 times minus 1 plus 2, which is 1, so then we have minus c is 1, right? If I'm correct. So this means that c is minus 1, and then if n is minus 2, we have this term goes out, and then we have minus 2 times minus 2 plus 1, which is minus 1, so we have 2 times b is 1, so b is 1/2 again. So let me substitute here. Okay, I'm gonna erase this thing here. So we have 1/2 of 1 over n, 1/2 of n 1 over n plus 2 minus 1 over n plus 1. Okay. Now, as usual, with telescoping series, we want to, so let me write the series, okay? This is n equals 1 to infinity, and then we have, let me write it like this, because this is also minus 1/2 over 1, minus 1/2 times 1 over n plus 1 minus 1/2 times 1 over n plus 1, okay? So we can multiply 1/2, and then we have 1 over n minus 1 over n plus 1 minus 1 over n plus 1 plus 1 over n plus 2. Okay, so writing it like this, you get the idea that we can name this u sub n, and then this, we can say this is minus this, which is u sub n plus 1. You see? So u sub n is 1 over n minus 1 over n plus 1. Or in other words, we can say this is n squared plus n, multiplying both things, and we have n, this is 1 over n squared plus n, actually. And so let's see, we know that the sum for a telescoping series is 1/2, okay, multiplying, and then we have u sub 1, because it starts at 1, minus the limit when n goes to infinity of u sub n, right? Well, the limit of u sub n is going to be 0, right? And so we have u sub 1, which is when n equals 1, this is 1 plus 1, 2, 1/2. So then we have 1/2 of 1/2, which is 1/4. Okay, so that's the actual value of the series. So yeah, the only hard part in a sense is to get from here to here. But whenever you have these kind of things that n plus 1, n plus 2, well, it's going to be something n minus n plus 1 and then n plus 1 minus n plus 2. So you need to manipulate these things so that you get to this kind of structure. Okay, it's not easy. So sorry, it's not hard, but it maybe take you will some time to solve this kind of thing. Okay, so try it again.